Hi, and welcome to another lesson in the physics video series. Today we will be discussing the resolution and resultants of vectors. Let's get started. In the two drawings that we have here, one on the left and one on the right, we're going to be talking about the resolution of a vector and a resultant of a vector. Basically, we're going to be combining vectors to create a new vector, as you see here on the right, or we're going to take a vector that's on an angle and we're going to break it down into two vectors, one on the x-axis and one on the y-axis. As you see here on the right, the resultant vector is what is obtained after addition or subtraction of a vector's components. So if I have the green vector and I have the blue vector and I put them here at 90 degrees to each other, I create a hypotenuse out of the two of these vectors. The green plus the blue makes the red. Whereas when I resolve a vector, resolve rhymes with dissolve, I break it down and I cross two little slashes through it to let you know that we're going to turn it into the leg and height of the triangle that makes a right triangle. You can see that the red vector will disappear, and in its place we will be looking at the green vector, which is called the x component, because it's on the x-axis, and the blue vector, which is the y component, because it is on the y-axis. Both of these pictures look identical, the one on the left to the one on the right. So what's the difference? The one on the left is where you start with hypotenuse and you break it down to find the legs, and you no longer care about the original red vector. But the one on the right, the resultant, is when you take the green and blue legs and create the hypotenuse. It all depends on what you need to do, whether you need to resolve a vector or to find a resultant of a vector. But these are opposite processes from each other. Let's take a look at the trigonometry. It is very simple because it is the trigonometry of a right triangle. If I want to find the resultant of a vector from perpendicular components, this green and this blue, we should recall that green is on the x, blue is on the y, and we would be looking at the Pythagorean theorem. X squared plus y squared equals the red resultant. And, of course, the angle that exists between the hypotenuse and the base angle, in this case the x component, would be equal to the arctan, opposite over adjacent. So it would be the y divided by the x. That ratio, take the arctan, and now you know the angle. So if you had to take an x component and add it to a y component, you simply Pythagorize, and then you take the arctan, and that's how you determine the resultant vector. It is the result of adding the green plus the blue. Now let's take a look at what happens if you wanted to reverse this process and break it down to resolve a vector. Resolving a vector into its perpendicular components is not too much different from finding the resultant. You're going to reverse the process. The resolution of a vector is what is obtained after it is broken down into perpendicular components. So if I start with any vector on an angle, it automatically is the hypotenuse to a right triangle, and we want to find the legs. So the basic trigonometry that we're going to use is SOHCAHTOA. The cosine is equal to the adjacent divided by the hypotenuse. And since the adjacent vector is on the x-axis, and the hypotenuse is the red, so it's the green divided by the red, cosine theta equals x over r. Solving for x, you get r cosine theta. And similarly, if I want to find the blue vector, that is the opposite vector, the sine theta is equal to opposite of hypotenuse. So that's y over r. Solving for y equals r sine theta. And this is what we have here using SOHCAHTOA. X adjacent equals the red vector, the hypotenuse, times the cosine of the angle. And the blue vector, the vertical component, is equal to the hypotenuse times the sine of the angle. Let me show you on the reference table that these two formulas are actually there. Here is page 6 of the physics reference tables. Under mechanics, you can see formulas 6 and formula 7. AY equals A sine theta, AX equals A cosine theta. And here they are. Here's your hypotenuse, and here's AX, which is a horizontal component, and here is AY, which is your vertical component. So you'll be using formulas 6 and 7, especially when we start parabolic projectile problems in the next video. And here it is in full page summary. On the left column, you have resolving a vector into perpendicular components. Resolve rhymes with dissolve, and you take the red hypotenuse and you turn it into the green x-axis and the blue y-axis component, as opposed to starting with an x component and a y component and Pythagorizing them to get the hypotenuse. These are the opposite procedures from the other. The left side breaks down a vector. The right side builds a new vector. We're going to use these, as I mentioned earlier, in parabolic projectile problems, especially the resolution of a vector, because this vector r, which will be any vector, will now turn into a velocity vector. And we're going to be interested in what happens when an object is shot through the air at an angle, and part of its velocity carries it sideways, and part of its velocity carries it up. That's going to be a separate lesson, but we will be using the resolution of a vector. So x equals r cosine theta and y equals r sine theta, formulas 7 and 6 respectively. Thank you for watching. I hope you enjoyed this video, and we'll see you in the next lesson.